Okay, so we're going to set up a Loadcoder cluster in order to be able to distribute our Loadcoder tests that we built over several remote machines. Let's start by going into loadcoder.com and the documentation for clustering. And here at the top we can find a brief description of the architecture of the cluster. So the cluster will be built upon three types of machines. One workstation, typically your machine that you're working from, and from here you will be able to manage your cluster, your remote cluster. You will also have a master node that will be running various kinds of services to manage the cluster, and we will also have one or several worker nodes that will be running the actual Loadcoder tests. And all of these services will be managed through the Docker API that we will be setting up right now. So the first thing we need to do is to choose our deployment method. And here, if we scroll down a little bit, we can see that three types of deployment types are listed. You can either run the entire cluster at your workstation. You can run it at a remote machine, one specific remote machine, or you can run the entire cluster at several remote machines. But for the sake of simplicity, we will just be using the first method to run the entire cluster at the workstation. The first thing you need to do is to verify that your workstation are set up according or meeting the system requirements that are listed here. You will need some substantial resources like storage, internal memory. You will also need to run Linux, and here is a description of the domain lookup. Preferably, it is best to have your machines in the DNS, but you can also configure them in the etc host file. And since I don't have my laptop in the DNS, we will be using the second method for this demonstration. So let's open etc hosts and add the mapping to 127.0.0.1 and a new hostname that you can choose whatever you like, that we'll be using also in the cluster. I'm choosing master node as the hostname, and we can also test out with ping that it works. Yeah, it seems to work. So now we should have everything in place in our workstation in order to proceed. So the next step is to define or to set up the Docker API, and we will do some configuration in the Docker service file. And in this file we will be commenting out one existing line and replace it with a new line. And this line basically instructs Docker how to start and how to expose the API. And we will be exposing the API at localhost port 2375. Alright, so everything should be configured correctly now. So basically what we need to do is to reload the daemon and then stop and start the Docker service. Yeah, and we can see that the ps command to list all the Docker instances or the Docker containers are working. And we can also check with netstat that the actual API is exposed at localhost 2375. So the next thing to do is to create a load test project. And this is basically an ordinary Java Maven project where you will have your performance tests. You will be creating a controller class that you will be using to manage the Loadcoder cluster. We will also have a test.sh file that the Loadcoder Docker container will call. And last but not least, there is a Loadcoder configuration file that will be containing all the information regarding the infrastructure of the cluster and everything else that needs to be configured. So this load test project you can of course create by your own from scratch if you like, but for this demonstration we will be using an already created examples project that we will download and extract. This zip file contains several other examples projects regarding Loadcoder, so if you like you can check them out as well. But for now we will need a project called cluster, so let's import that into Eclipse. Okay, so if we expand these packages, we see some classes. One class called simple load and another class called controller. And the simple load class is actually the Loadcoder test that consists of 3 transactions. We have a load part that consists of 5 threads. We're ramping up over 20 seconds. The test will run over 600 seconds. And we also have result consumer, Influx database. So we will send all the results to the database. And here we have the controller class, and as I mentioned before, this is where you actually will manage the entire cluster. We also have the Loadcoder conf file, the configuration file of the cluster that contains information about the container images that we will use. We also have a configuration of the infrastructure of the cluster. And here we point out that the node with ID 1 is our master node. And the host is configured to the same host name that I configured in the etc host file earlier. And since this node that we're using to host the entire cluster can't be looked up through DNS, we will also need to configure this mapping so that it will show up inside the container. But for this configuration we can't use the same IP that we used in the etc host configuration. What we need to use here is the IP that our host machine is exposing to the outside. So let's hit the ifconfig command and look up the correct IP that we need to have. Okay, so now we have the correct IP that our Docker container will be able to reach. And in the root of the project we can find the test.sh file that the Docker image is instructed to call. And it's a very simple bash file, a Maven command that is pointing out which Loadcoder test to run, and we are redirecting the output to a configuration file that you can find in the exposed volume at the host machine. Okay, now we should have everything in place so that we can start the Loadcoder cluster. And we'll do this by opening the class controller and uncomment the line cluster.setupMaster. So the first thing we need to do is to set up the Docker containers that will run on the master node, which is the workstation in our case. And these containers are one Influx database, a Grafana instance, and a special service called Loadship, which is a part of the Loadcoder stack that will distribute the performance tests. Okay, so let's run this, see what happens. Okay, we get some output that says that these services are started. So let's open a browser and we go to localhost.3000, which is the Grafana endpoint. So we have logged in and we can go to dashboards and we see that, okay, it's a newly started instance. We have no dashboard set up yet, so that's fine. Okay, since the master nodes are now started, we can comment that line out. And the next step is to upload our project to the Loadship server. So we will now run 2 lines, the upload test and the start new execution. So what happens now is that the controller will zip and upload the entire project up to Loadship and then start a Loadcoder instance. So if we run docker psa, we can see that we have a newly started Loadcoder instance, and we also have the master Docker containers running. So now the Loadcoder test is started. And if we switch back to Grafana real quick, we can see that we still don't have any dashboards, and that's because Loadcoder isn't creating dashboards by its own. You have to explicitly do that. So let's comment these lines and uncomment the lines about Grafana. So here we will create a Grafana dashboard. And I can also mention that these strings that are used as parameters here, they need to match up with the strings that are used in the load test in the influx database client, where you specify the result consumer, so they need to be equal. Let's run these lines. Okay, so we should have a dashboard. Go to Grafana, and yeah, we have a directory called simple tests, and inside of that we have the dashboard. And this dashboard shows the ongoing Loadcoder tests. We have 2 charts. The chart above shows the response times of the 3 transactions that were stated in the Loadcoder test, and the chart below shows the load level. Now let's do one other thing. We comment out these lines about Grafana, and we uncomment the line about scale existing execution. So this line, or this method, takes a parameter called 1. So we here state that we will scale the load at the node 1. So if we list the Docker containers again, we see now that we have 2 ongoing containers that runs Loadcoder. And if we go back to Grafana now, we can see in the load chart that the load is ramping up. It should hit 20 transactions per second. Yeah, it seems to stabilize around 20. So for the last part, we will stop the execution, and this is done, of course, simply by running the method stop execution. Okay, So we see that in the output that container 1 is stopped and container 0 is stopped. And if we switch back to Grafana again, we can see that the load intensity are quite drastically ramping down. So, test finished. Yeah, so this was a quite brief introduction of how to set up a Loadcoder cluster at your workstation.